Very good morning to all. Very good morning, Professor Monto.
Good morning.
Good morning, Professor Prasad Raju. So, welcome to the second day of a 3-day national level faculty development program on sustainable engineering. Today is the third session. So, the third session is by Professor Monto, Professor of Indian Institute of Science, Bangalore. He is the Director for Sustainable Engineering Laboratory. So it's my privilege to introduce him.
So can I proceed?
Yeah, 1 minute. Dr. Monto is a professor, Center for Sustainable Technologies, formerly Astra, Center for Product Design and Manufacturing, Indian Institute of Science, Bangalore, India. He did his BArch at BKPS College of Architecture, University of Pune, and Master and PhD at IIT Madras, Chennai. Dr. Mani has supervised more than 130 individual projects on sustainability assessment as part of the course Technology and Sustainability. He has co-authored a book on sustainability in human settlements, co-edited 3 books, and has extensive international journal and conference publications on diverse areas pertaining to sustainability. He has been guest editor for a special section in Current Science and Design for Well-Being published in 2015. Dr. Mani has received Cambridge Hamid Fellowship for academic collaboration in areas of sustainable manufacturing and smart buildings at the University of Cambridge. He is panel member of Bureau of Indian Standards National Building Code 2016 on sustainability considerations in buildings. Dr. Mani is currently coordinating a scientific study on the Kaveri River Basin, specifically looking into the biodiversity and sustainability. With this brief introduction, so I'm privileged to have you on the board, sir.
Thank you.
So thank you very much. So now I request Dr. Monto to take up the session, sir.
Yeah. Very good morning, Professor Ishwar, the dignitaries and the participants. I'm really glad to connect with all of you. Is my screen visible?
Yeah, visible, sir. Sir, unmute yourself. Yeah.
Yeah. Am I audible now?
Yeah, audible and visible, sir. PPT is visible.
Right. Yeah, so I will recap. My work is on sustainability, buildings and design. And I will be sharing with you the challenges that we have come across in the area of sustainability in buildings. The fact is that we spend a lot of time in buildings, and buildings come in various forms and configurations, like the picture that you see on the screen. On the left, you will see buildings on the same street, variety of them. You have a double facade building like the one with holes here, and you have a completely glazed building. One could be naturally ventilated, the other could be completely air conditioned. Then in the middle top, you have buildings in rural India, which many of us will be familiar with. This is in West Bengal, in a place called Nayagram. And right below that, you will see a photovoltaic panel roof. This is our lab at the Indian Institute of Science, where we built a photovoltaic roof integrated system way back in 2006, 2007. It still stands. And today it's a 10 kilowatt, nearly a 10 kilowatt grid interactive system. And on the right hand side, we have another building, which is a commercial building, which is completely cut off, meaning it's an air conditioned building. And the fact remains that even before the COVID-19, we spend a lot of time indoors. With the COVID situation, we are probably spending more time at our residences, like what I'm doing now, in terms of schooling, managing research, and things like that. So buildings play an important role in the productivity that we have. And way forward, even apartments today will look at having a small space earmarked for offices. Because take Infosys, for example, 95 to 98% of Infosys today works from home. And the entire IT industry is looking at the fact whether it is necessary to have all the IT infrastructure, like huge offices, huge establishment, because operating and maintenance costs are very high. And if people can work from home, then it is easy for them. There are also other advantages like improved productivity, simply because you don't have to spend 2 hours, 3 hours traveling in traffic, and your exposure to pollution and things like that. Parents are also happy if the children are at home, supposedly better to manage. And they're also having a very interesting experience, like our son is having right now. He's having online classes. So way forward, it's a very different experience. And even, for example, this year we conducted interviews online, and it was a very positive experience, which means that we can always relook at the fact whether some students need to travel all the way from, say, the northeast or Jammu and Kashmir to come to Bangalore to take an interview, right? So indoors definitely have a big role to play. And moving forward, I will be discussing some challenges. So starting with the whole concept of ecological capacity. Is my slide visible now?
Yes,
Is
sir.
my
Yes,
slide
sir.
visible?
Yes,
Yes,
sir.
sir.
So what you're seeing here is a metrics of satisfaction with life and ecological footprint. What ecological footprint means is the terrestrial, the land area required to support our lifestyle. So it is measured in terms of global hectares per capita. And today there is again a complete new concept of wellness, where people are looking at holistic living, mental health, physical health. So here the metrics of satisfaction with life was, am I happy? Do I have time with my family? Do I have time with my friends? Those sort of things, rather than look at what is my income level, what is my take home salary, do I have insurance? Those were, what is the GDP? Those were the initial performances of prosperity. Today, they are looking at a different measure for it. And if you look at the countries, you take United States at the top, which has almost close to 10 global hectares per capita, with a very high satisfaction with life. On the other end, if you look at the poorer nations like India, Bangladesh, Pakistan, you will see that they have a much higher satisfaction with life with a much lower ecological footprint. Now, this will also bring forth the distinction between Western philosophy and Eastern philosophy. Western philosophy believes that go after your desires, satisfy your desires, and then you're happy. But desires don't have an upper limit. So today you will want something, tomorrow you will want something more. Unfortunately, the current economy that we are depending on is based on consumerism, which means that tomorrow I should consume more than today. So fundamentally, there is a question here as to, can we talk of sustainability when the economy is based on consumerism? The Eastern philosophy, on the other hand, says that have no desires and you're happy. And the balance part there is, up till retirement, we follow the first half. Post retirement, we follow the second half, right? Where we say, oh, I will now look at social service, relationships are more important now. I will not worry so much about money. I will devote myself to environment. Those things come after retirement, when all the damages during our professional careers we have already done, right? You know, those are the facts that also comes at the personal level when we look at sustainability. Coming down to this fact again, that since the 1950s, since the industrial revolution, the income levels of people has gone up, but their happiness levels have been declining. And this is very evident even in cities today. 10 years back, the kind of happiness levels, or 20 years back, the kind of happiness levels, and now are very different, right? So we have to relook at the concept of happiness. And with this whole COVID situation where we were forced to stay at home, forced to put up with a lot of activities happening parallelly, managing school, managing office, managing the home front, it has also brought forth the fact that we need very little. Earlier we were wanting to travel every time, didn't have time to go to office, the traffic. What this corona has also taught us is how much little we actually need to survive. So if we relook at reopening the economy and going forward, it has already taught us a few lessons in terms of, okay, do I continue the way I was continuing before, or can there be some improvements I can take from? Definitely it has caused a lot of grievances, a lot of deaths, no doubt about it. But at the other end, if you look at what opportunity has it given us, it has given us an opportunity to stop and think as to, should I continue the way I was doing, or I was continuing before the whole COVID situation started. And this is happening across the world. Construction industry is looking at green approaches now. Industries are looking at greener manufacturing options, looking at net zero energy, things like that, which didn't happen before. Now, I will also try to distinguish between zero energy and energy zero. The house on the left, if you see, does not have electricity supply. And these were houses that I started studying way back in 2003, 2004. So they don't have electricity supply, and electricity supply is the energy of the modern world, right? And on the right hand side, my laboratory, I am trying to say I'm generating as much energy or more energy than I consume. So I am energy zero. Both are not the same. Not requiring electricity at all and generating as much electricity as you consume are both not the same. I'm not saying that the people on the left don't use energy. They use firewood. And if you compare the health levels of those people versus the health level of people in the city, you will always say that people in the villages are healthy. There is always this concept of development, impoverishment, deprivement, drudgery, which we associate in the village. And unfortunately, today, that is also taking a very different perspective. And I'll give you an example. I go to a village market every week until this corona issue started, where I used to find ladies lift heavy bags of vegetables. And if you see the way they lift the vegetables, it looks like they're doing a gym workout, right? Now, the problem is that any engineer who will see it will say, oh, that is drudgery. Ladies are not supposed to lift that much. If you go to a village farm, you will see that villagers are doing hard work through the day. And we say, oh, that is drudgery. We need to give engineering solutions to that. We provide engineering solutions. And then what happens is that people take to a very convenient life, very comfortable life, because of which obesity starts to set in. And because of obesity, you go to a doctor or a dietitian and he tells you change your diet and go to the gym. You go to the gym and you have kettle balls, those round heavy balls, which you lift to do some exercises. And there is a gym exercise called the farmer's walk, which means that you carry those two kettlebells, walk up and down a gym which is air conditioned, and that is supposed to give you a whole body workout. When the farmer does it, you call it drudgery. When you do it in the gym, you call it a workout. Right. Now, it doesn't just stand there. There is also another problem where when the farmer does it, the food that he eats is utilized productivity, is used productively in the farming activity. Whereas when you do it in the gym, you're burning it in the gym and that energy is of no use at all. That the efforts that you put in is of no productive use at all. Right. So then you can understand the context of food, where when you live in the city, lead an obese life, go to the gym, your food consumption is also much higher than a person in the village. Forget the fitness level. The fitness level of people in villages is way higher than people in the city, right? But unfortunately, we consider that life as undeveloped, poor, impoverished, with drudgery, right? So this concept is again completely being relooked at today, right? Walking barefoot was considered bad at one time. But if you today look at documentaries like Earthing, you will find that the Western countries are facing serious problems of inflammation, serious problems of diseases because their body is not touching the earth. So now doctors are recommending that you should take some time off and walk barefoot on earth. And there is also something called an earthing mat, whereby an earthing wire going to the ground is connected to a mat on which you sleep, right? And that is available on Amazon. And there are medical studies which have shown that if you are sleeping in a mat which is earth, your sleep is better, your body heals faster, the inflammations inside the body are much lower, right? And these are all scientific reports. They are not some old man coming and telling us, oh, it is always good to walk on the ground, right? I will also tell you the context of embodied energy and operational energy. Embodied energy in buildings. Am I audible? Am I audible?
Yes, sir. Yes,
Sir,
sir.
you are audible.
Yes, sir.
So here I'm just giving you a context of energy in buildings, where the bottom right that you see are vernacular dwellings, traditional village dwellings, where embodied energy is less than 2 gigajoules per meter square. Embodied energy is the energy going into manufacturing and transporting and installing building materials, right? What I meant by installing is, if you're using precast members, you have a crane which has to come lift it in place. There is energy going into that. So embodied energy accounts for all of that. Operational energy is the energy required to keep the building comfortable, right? Even, for example, if you have a house which is very poorly lit, you need electricity to drive some bulbs because you need to work in that room. That is operational energy. You will see that as we come four. And if you go to ultra modern houses that you see on the left, the embodied energy goes from 1 to 42, right? And what we were trying to do here is to see what energy sources are feasible to provide for these sort of energy requirements, energy demands. So if you look at villages, a small photovoltaic panel is enough to meet their energy requirement. They might want to run their television, maybe their grinder, charge their mobile phone, that's it. When you come to the city, you need more. You have a microwave oven, you have a washing machine, you have a dishwasher, you probably have 2 or 3 televisions in the house, right? Because each one wants to see his own channel. And when you go to an ultra modern house, that's a lot more, right? Because you have an air conditioned space, you have lifts to bring you up and down. So you will see the nature of energy densities that are required. And for example, large power plants covering desert areas. Today, large power plants, large photovoltaic systems are covering agricultural lands to provide for city-based energy consumption. The challenge we have here now is that villages are also changing. At one side, it is good, where we say that modernization should happen. They also have a right to access modern life. On the flip side, we are losing the skills associated with these materials. We are losing the technical know-how with these materials. And I will also tell you why that is important. And what is happening is that their energy dependence also increases because the way the houses are changing, first the roof changes, then the wall changes, then the entire house changes. The houses become more uncomfortable, which means they have to demand, they need fans, they need air conditioners after that. An air conditioner then becomes a lifestyle requirement. Now, with this transition, it's happening in China as well. Now, why the world is worried about India and China is simply because worried in both sense. One is an opportunity, the other is a threat. The opportunity is that 1.8 billion people, say about zero point 0.6, zero point 0.7 billion in India and 1 billion, 1.2 billion in China are rural population. And if these rural population are going to improve their lifestyle, adopt a modern life, it is very good for the economy. Economy will grow. Right? The threat side is if they start adopting 40 times, 50 times the resources that they were originally consuming, do we have the capacity to provide for those resources? What about the emissions associated with those changes? We are already having threats of climate change. And if that is going to increase by 40 times, then how do we address this situation? Right? So the challenge becomes how do we regulate their aspirations, provide for their aspirations, while trying to keep the resource dependence, the ecological footprint, and the emissions lower. This is the estimates that we had made in 2012. And what we found is that if the houses were just changing material without the form changing, there is a 6 tons of carbon dioxide emissions per house, right? And if you then project it further, we will find that these embodied energy alone can moderate about 10 to 15% of 2030 projection for GHG emissions, right? And if you also look at the operational energy, I've looked at the very basic operational energy. These were based on our own studies in villages, matched with the government reports on purchasing power, appliances, appliance efficiencies, adoption of energy efficient measures, and all of that. What we find is that this projection is not yet accounting for embodied energy, the rebound effect. What rebound effect states is that when appliances become more and more efficient, they become more affordable and people start to own more of those appliances. So the net result is because of using energy efficient devices, our net energy consumption actually goes up. It doesn't go down. And that is a serious problem because even if you today go to Google and type rebound effect, you will find that places like Germany and all are having problems of 200%, 300% rebound effect, right? And the thing is, I mean, take our own lifestyle. What I was consuming 10 years back, my own energy, and what I'm consuming now, I'm consuming more now than I was consuming 10 years back. The computer that I'm using is more efficient than the computer I was using 10 years back, right? And this also is visible in villages where at one time there was just one television to a village showing Doordarshan, and Doordarshan will operate from 7 in the morning till about 9 o'clock and about 7 in the evening to about 9 o'clock. And the village used to get together to say see one movie or maybe a cricket match, discuss, so the social unity was much better. And with that, they will switch it off. Now every house has three TVs because my parents want to see a different channel. Almost 6 hours, 7 hours of the day, they're sitting with that. I want to see a different channel. My son wants to see a different channel, right? And today I can afford television because they're very cheap. Though they are very cheap and energy efficient, my net energy consumption is going up, right? Not only that, it is causing fragmentation in the family because each within his locked room because sound disturbance should not be there from one room to the other, and God only knows how much time we are spending with ourselves with the television, right? So there is also a social fragmentation happening. People, we don't take into account these factors when we adopt technologies, right? This was a study that I was telling you about vernacular dwellings. Our students actually presented this last year at the conference in Heriot-Watt University in Dubai, where it was a conference on comfort at the extremes, looking at how climate change is going to impact dwellings. And what we did is that we took us a few dwellings in rural Bangalore and studied if their temperatures and humidity conditions were going to change. Say if they were moving from warm, humid as they are today to temperate zone, and what if they move towards hot, dry zone, right? And we looked at both traditional dwellings and conventional dwellings. Conventional dwellings are what you see in the city. And what we found is that if you look at the graph here, the graph is indicative of the adaptive comfort model, which says that our body has the ability to adapt depending upon external comfort, external temperature conditions. So we feel comfortable at a higher temperature in summer than in winter. Example is, if the outside temperature is 40 degrees, I might feel comfortable at 30, 32 degrees, right? If the outside temperature is 30 degrees, I might feel comfortable at 20, 22 degrees, right? Naturally. So I don't need to have a constant temperature, which we usually use in the air conditioner. So this adaptive model takes into account the response of the indoor comfort requirement in response to external temperature conditions. And the gray band that you see is the 80%, sorry, the 90% acceptability limit. And the wider band shows the 80% acceptability. And what we found is that as of now, conventional dwellings require fans because their natural ability to provide comfort is less. Whereas vernacular dwellings more or less lie within the 80% band, right? Which means that the dependence on electricity is much lower, like fans and coolers, Then if they get warmer, hot, dry, you see how bad the conventional dwellings are going to respond as against vernacular dwellings. And if it again goes to temperate, you will see that the vernacular dwellings perform very well. So whereas climate change is concerned, their impact on traditional dwellings, which we call as undeveloped or poor or requiring to be modernized, are anyway performing way better than any conventional dwelling that you can think of. Right? Now, so the reason why I'm saying that is that traditional dwellings have a lot to teach us. We need to scientifically move forward in a direction and see how can we retain traditional dwellings the way they are and probably provide them a modern life. Otherwise, if we change completely, the energy requirements we're going to need more than the 40 times energy that we are already estimated. We will not be able to sustain that. Then coming to photovoltaics. See, everyone says photovoltaics is green. But if you look at the reports since last month, the government is now coming up with a contingency plan for what to do with photovoltaic panels that are discarded, what to do with waste photovoltaic panels. And we are talking of a few 100,000 tons of photovoltaic waste coming out every year, starting from 2030. Because though photovoltaic manufacturers claim a life of 20 to 25 years, they are decommissioned in 10 years, 12 years because they are economically unviable. Degradations are much higher. Degradation rates are much higher. And maintaining them becomes a problem. So what do we do with these panels, right? So that is a serious issue. And you can't take them to the dump site. You can't easily extract the silicon, recover resources, because those technologies are still very, very, very uneconomical in terms of commercial scale, right? Germany is doing some work. IIT Bombay, there is a group doing some work. All over, there are some research activities happening in this area. But we have not thought about what happens to these panels at end of life. right? Even in the operation of these panels, it is very challenging. So this was some work that we published way back in 2010, and it is actually the single most cited paper in the area of dust impact on photovoltaics, right? And in fact, the paper subsequently went into supporting a lot of projects across the world, and including what we have this Indo-US consortia here. And what we did here was to understand the various mechanisms that influences soiling. And soiling has a very detrimental effect on the performance of the PV panel. Right? The example here is dust. I'm giving a simple example. And dust will directly affect the output of the panel. Depending upon the dust density, this is the IV curve. And you can see that within a week or two, and if depending upon the exposure, if you're close to the road, the dust density settling will be much higher. If you're in an open terrain, the settlement will be much higher. And people don't know, or people are not aware, that it takes about half a liter of clean water per meter square per day to keep the panels clean, right? So you can imagine for a megawatt scale level where there are a few tens of acres of land utilized, half a liter of water per meter square per day of clean water is a lot, because there is scarcity of drinking water, right? And I know there is a power plant in Sri City which is buying mineral water to clean the panels, simply because the groundwater salinity is very high and that causes stains on the water. We cannot use seawater to clean the panels. So what we did is that we tried to look at mechanisms to reduce the water requirement to clean these panels, and brought it down from 500 ml to 50 ml. And then we looked at other phenomenon that was happening at the surface between the solar radiation and the panel when there's a dust layer in between. And here we used simple brooms, palm leaf brooms, which are used in villages. And we found that palm leaf brooms are extremely effective in taking up dust without the need for water. And they are also very easy to maintain, because we put the edge of the palm leaf under the scanning electron microscope. And we found that the tips are like that of a shark's teeth. With every layer breaking off, there are more edges, sharp edges coming out, which means that the brooms are actually able to retain their cleaning efficiency as and when you use it. I will also come to another aspect of smart buildings today. And there is a lot of work that across the world people are doing, saying smart buildings will reduce energy, will make places more comfortable and all that. Now the whole corona has pulled the gas out of that belief. Today, the ASHRAE standards, the American Society for Refrigeration, air conditioning, they are clearly stating, we need to bring in fresh air inside the buildings, even in an air-conditioned building, simply because air conditions will tend to recirculate air within the building, which is bad from a corona point of view, a COVID situation. So the entire air conditioning code needs to change, right? People are now looking at opening windows, allowing fresh air inside, because air conditioners will spread the disease, right? People are looking at sitting more spaced apart, whereby the air conditioning load again will be higher, because instead of a room occupying 20 people, there are only 5 people sitting in that room, right? So this whole concept of smartness has been punctured, right? And I will tell you another example. This is some work that we started about 3 years back, is where do we put energy sensors or energy neutrality sensors, okay? Now, what I mean by energy neutrality is that if you take a small sensor, say a motion sensor, which detects activity within a space and switches on a light, where does it make sense to put them, and where does not make sense? And we did an example, like I said, an LED bulb and a sensor, and we looked at the life cycle energy of the sensor as to where was it manufactured, what are the components inside, where were those components manufactured, what were the semiconductors used in those, where were the semiconductors sourced, then finally, where was the packaging material made, how did it come to us, So we even looked at the delivery, energy which Amazon took to transport this all the way from Shanghai to Bangalore, Bangalore to IISc, right? And what we are saying is that if there is a sensor installed to save energy, then what is the time it will take for the sensor to save energy, which will exceed the energy going into its own manufacture or installation, right? And what we found is that in the case of LED, the sensor energy, the embodied energy associated with the sensor is much higher than the energy it is saving when connected to LED lamps. Okay, and I will tell you why that is happening. So this is what I said. We looked at all the data very minutely and said that what happens if a sensor is manufactured in Shanghai, brought and installed in Bangalore in a building. And we came up with this measure of gram per wattage ratio. What the gram per wattage ratio is, the grams of the sensor, the smart network, connected to the wattage of the load. And what happens is we took a few examples of, say, filament-based bulb and the energy payback period as against LED bulb. Now, the problem is that with LED bulbs, the energy payback period is much higher because the bulbs are already very efficient, right? If a device is inefficient, then the scope to save energy is much higher, right? So it might be possible that you put LED lamp in a room, switch it off, switch it on whenever you feel you need it without installing it to a sensor, because connecting a sensor will completely change the energy dynamics if you look at the building scale. And in fact, the student who's working on it also went to the University of Florida to do work on this. And we are trying to now come up with recommendations for smart buildings to say that, okay, putting sensors for these appliances makes sense. Putting sensors for these appliances does not make sense, right? There is also another problem. We looked at behavioral changes. And what we meant by behavioral changes is we installed this in the office, where as soon as we enter the office, light goes on, right? And when I leave the office, light goes off. Now, at the subconscious level, I start getting trained to think that I just have to enter a room and light goes on, and I just have to leave the room and the light goes off. I'm behaving the same way at home, right? So at home, when I come in, the light does not switch on, so I switch it on. But then when I leave the room, I am assuming that the light will switch off, and it does not. And very often, whole night the light is on, and I'm burning energy there because there's a behavioral tendency in me to believe that those lights will switch off by itself, right? So if you look at the entire energy associated with my lifestyle and account for all of these, are smart sensors actually resulting in me reducing my energy consumption? It may not, right? And these behavioral changes, even my students observed when they went back home, right? So these are some measures, like I was saying, that if the sensor were made in India as against the sensor were made in China, the entire life cycle energy matrix changes, right? And this also comes back to, from a sustainability point of view, why should we consume local resources? Why should we consume local skills? Why should we not depend on, why should we depend on materials that come from far away, right? Finally, I will also take you to the concept of safe lighting. Today, LED lights are a source of a lot of problems. In fact, even our mobile phones have something called night mode, because excessive use of LED lights is causing a hormonal imbalance in us, which prevents us from sleeping at night. And this happened on campus, where I was chairing a committee looking at installing LED lamps on campus. And the moment we started installing it, we started getting reports of students complaining of eye stress, eye pain. There were a lot of other nocturnal wildlife disturbances which were also reported. And not only that, we changed our lights in the laboratories to LEDs, and students were complaining of eye pain. And what we realized is that when we measured various light sources and under a spectrophotometer, we found that the yellow light that you see here is the natural spectra that comes inside. This is the wavelength on the x-axis. The incandescent bulb, the filament-based bulb, which we say is the most inefficient, is the closest as far as natural light is concerned, right? When we look at LED light, there is this blue peak, which is much higher than what our eyes are normally able to withstand. And if you look at medical journals, if you look at a lot of reports from the American Medical Association, they are already banning white lights. If you buy any LED lamp and look at the small leaflet, the industry clearly says that please do not stare at the light directly because it damages the retina. It causes irreparable damage to the retina. Right. Now, where do we look at sustainability now? We are looking at efficiency, but the efficient appliances that we are depending on is causing other problems, right? And even I was not aware of this until 2014, when there was a professor from Germany who came and who said that, Monto, do you realize that when people work under LED lamp, they are short-tempered, hyperactive, impulsive, and the tendency for productivity to go down is also high, because the white light that you get from these lamps causes hormones that alerts the body. The body becomes very, very alert. Now, the thing is, in the daytime, you get this level of white light for a very short period. Your body cannot be alert at this high levels for 8 hours a day, 10 hours of the day. It causes other problems, right? And that is why when you stare at your mobile phone at night, you are sleepless, because the radiation from the mobile phone is generating hormones. It interrupts the the sleep cycle, and then it gets messed up, because if you're not slept well, the next day you're more irritated, less rested, you're not as productive as you are, right? So finally, we identified a filter. The filter is called Kapton, Kapton. It is commercially available on Amazon. It's a simple polyamide film. And the advantage of that polyamide film is it can withstand the temperature coming from the LED lamp. So we made this information available to the public in this article that came out in Down to Earth, where you can actually put these Kapton tapes on LEDs to make them safe. Now, that filter is able to take off the blue light. As far as safety of the eyesight is concerned, it has definitely helped. But in terms of color rendering, representing the color as they are under those lights, there are some limitations. But the entire IISc, we have put these tapes, almost 1,500 to 2,000 lamps across campus. A lot of industry have approached us to find out how we do this, how do we adopt these filters and all of that. But we made it freely available to public, so that, in fact, I have received so many emails. There was one email that I received from a lady who says that the husband changed the lights in the house to LED, and they had a light bluish color on the wall. And from the time they are in that house, they're having issues of eye inflammation. And the husband is most of the time away from the house because going to job and coming back. So the time at home is very less as compared to the lady in the house. And then I shared this article with her, and I told her that, see, there are problems with LED lamps. And today industry is coming up with what is called a warm white LED or a neutral white LED, which we have tested. Even warm light has a little bit of blue light, but it is much lower than the cool blue light that is otherwise adopted by industry. And to us, it feels very good, because as soon as we stare at it, our body generates hormones which makes us feel alert. And when we feel alert, we feel good, right? And that is why that it causes a very momentary feeling of goodness, which actually in the long term is bad. So I have some questions. Like I said, people say low energy, but we have challenges of rebound effect. People say minimum pollution. Now, if everybody causes minimum pollution, what happens to the earth? And now we are already having problems of microfibers, nanoplastics, microplastics in human tissue, right? Low impact. What is low impact, right? So finally, we have to ask ourselves a question: how low is low? How efficient is efficient? So we need to move away from efficiency and move to effectiveness, because efficiency is actually failing. It's not taking us forward as far as reducing our net energy consumption is concerned. So finally, I would conclude with this slide that we need to scientifically validate traditional practices, traditional wisdom. That is also recommended in the IPCC report, because India is gifted with the diversity of materials and vernacular architecture and practices, including diet, which has answers to problems of climate change that we are expecting to face. Even for the COVID situation, there are a lot of, the medical fraternity may not believe, but there are a lot of traditional practices, traditional medicines that are working in improving the immunity as far as the COVID situation is concerned. So unfortunately, once we are exposed to a completely different school of thought, our minds are not amenable to look back at tradition with an open mind. So I will stop with that. If there are any questions, I'll be happy to take.
Yeah, thank you very much, sir. So I request the participants to raise your hands. So if you have any question. Sir, I have a question, sir. Monto Mani, sir.
Yes, please.
So we are very much interested in cost effectiveness and efficiency, but as there is no regulation, so with regard to sustainability is concerned in policy making. So how people will try to adapt this? So majority of these dwellings are constructed by the contractors or individual people. So definitely individuals may not be aware of sustainability and all, but contractors, they don't want to use sustainability because the cost of construction will go up. So what is the solution for this, sir?
See, there is a price to pay here because of our unavoidable dependence on contractors. If they can be sensitized into adopting these traditional or alternative practices. Now, IISc, even for example, my colleague Professor Reddy, he conducts a lot of workshops to train people on alternative building practices. We conduct workshops twice a year, and that helped a lot. And many of the participants are contractors, many of the participants are architects, many of the participants are civil engineers. So I think awareness and confidence building is the way forward. And once momentum gains up, people will also be a little more comfortable with adopting these technologies, have a greater faith in these technologies. Because first and foremost, the person for whom it is being built, he might recommend this to his neighbor, but he may not adopt it himself.
And yeah, thank you, sir. One more point is, see, there is a conflict of opinion that is going on in between civil engineers and architects in the country. So that is also creating some hurdles.
Yes, that is definitely causing hurdles. And the problem there is that architecture and civil engineering at one point in time, even in the education, was very, very intricately, they were together. Now, what happens is that architects will design something saying that, oh, my building will perform like this. Oh, my building will give you comfortable things, and we'll think of some new form. And then the civil engineer takes it up, and then he says, oh, it is difficult to build. I can't do this. This material is not available, and things like that. So if both go hand in hand from the start, keeping a particular objective in mind, if they say that my house will perform well without the need for air conditioner, and both work together towards that goal, then it is feasible. But in the current practice, the way it stands, there are some limitations because of the inherent disconnect between the architect and the civil engineer. Statistically.
Yeah, thank you, sir. There is a question, sir. Should we get back to the rural building type where energy consumption is less than that of the dwellings in cities.
Yes, if it is possible so. Because if you look at the costliest of health resorts today, you will find they will build according to rural practices. And you will have to pay heavily to go spend a few days in those sort of health resorts. If for those who have it still as an option, nothing like it. Because there is an increasing realization among rural dwellers itself that their lifestyle is better. But then we'll have to match up with aspirations of the younger generation. Younger generation is far more sensitive than the current generation in terms of environmental and sustainability related concerns. So it is definitely a challenge. See, for example, rural house, can you build a wall in the city with 15-inch thick mud wall? People will immediately say, oh, I'm just losing carpet area, I'm losing floor space. The land is so costly. See, how can I come up with a glass facade which will give me performance of a 15-inch thick mud wall? So those are the scientific challenges we also have. We can't. So the problem is fundamentally we've become very greedy. We want everything, right? And the economy is also built on consumerism, which means that we should be more greedy tomorrow than I'm greedy today. So until in other ways what I'm coming to is that there is some liberty, some flexibility we have at the personal level in terms of choices we make. And I think that has a greater bearing on the sustainability front.
Sir, please suggest how we can live in a building with energy sustainability.
See, if you can live in a building with the energy consumption equaling the energy that you receive, okay, and that is a good metrics, is that if I take a 100 square meter building or 1,000 square feet building, what is the sunlight I receive on that building? Can my energy requirements of the building be kept within those sunlight that I receive? If you can do that, design work and work backwards from there, I think there is a good possibility to do that.
Sir, is it possible in the urban environment to have the housing similar to rural dwellings?
Performance we can expect, yes, but it will not come with, we'll have to look at a win-win situation here and not, how do I put it? Not exactly, okay, I'll take back that win-win situation part. We want everything. We want a modern look. We want maximum floor area. We want compound to compound construction. We want greenery, but we don't want to be having plants in our compound. So unless otherwise we are able to resolve that contradiction within us, it will be very difficult to achieve this. But it is possible to live within, say, a huge apartment complex with the parking area and with your play area. If you take that density, and if we say that I'm going to survive on the solar energy coming within that land, there are energy efficient ways. We have to keep our per capita energy consumption also capped up. We cannot say that I want to increasingly consume tomorrow, I want to increasingly lead a convenient life, and assume that I will still be sustainable and live like my forefathers did in villages.
Yeah, so is it possible in cities to have more ventilation and air conditioning?
These are contradictory things. See, this air conditioning is a big thing now. In fact, there is a report that I even read yesterday. You can look it up. The report says, what is the air conditioner secretly doing to our health? Right? Today, people are studying sleep cycles, how they are disturbed based on constant noise coming from the air conditioner, the air conditioning fan switching on, switching off, how it affects the deep sleep cycles within us, right? Now in cities, we were part of a large project which tried to look at dependence on air conditioners and increase in air conditioning consumption or purchase of air conditioner. At one time, air conditioner was not affordable for people, so everybody did not afford it. Today, Bangalore, which was at one time called the garden city and air conditioned city, the maximum sales of air conditioners is happening here. Many reasons. Pollution level is going up. So people think that if they put an air conditioner, the inside air will be cleaner, which is again not true. people also think that if they put an air conditioner, they can shut the window and prevent noise coming from outside to the inside. That is also not true. If you have an air conditioner, you cannot have ventilation because both don't go together, right? So by and large, today with the COVID situation also, nobody will recommend air conditioners because the filters will hold the virus and spread the virus to other places. So even huge malls in Bangalore are now operating under naturally ventilated conditions. And once the COVID situation gets over, even the refrigeration standards will change to account for more fresh air to prevent spread of infections. So we'll have to see. We'll have to see. The solutions are not that easy.
So no other questions, sir. So
Okay.
thank you very much, sir. Monto Mani, sir.
My
So
pleasure.
I'm happy that you are here. So to educate all the participants on sustainability in buildings. So it is eye opener for us. So how energy consumption is going to be changing because of this COVID situation. All these air conditions, all these electronic items which are used within the household, how they are going to change their manufacturing or product design, whatever it is, the principle of design also will change. So thank you very much, sir. So
Yeah, my pleasure.